Okay, now let's move on to the second part, training a linear regression model. Okay, so first we have to split out our data into an X array and Y array. We've mentioned that previously, X array gonna take would contain the features to train on, and a Y array is within a target value or the target variable. So in this case will be the housing price, which is our price column here. Oh, by the way, we're gonna toss out this address column because it only contains the text info that our linear regression model cannot use. All right, let's get started. So first we have to define our X and Y arrays. So X, as I said, these are feature columns. So I'm gonna take everything from average area income all the way to the area population, right? So what I can do is I'm gonna copy everything here and passing that to my X array. So I will use capitalized X to define the X array and USA housing, and let's paste everything, the feature columns here, and then I'll have a lowercase y to represent a Y array. Will be USA housing. We only have one column, which is the price column, this target variable, right? Okay, so here we have defined X and Y. Next thing is we have to split the data into a training set and a testing set. So we'll train our model on the training set, and then we use the testing data set to evaluate the model. So that's the basic logic here. The good thing for Python is it offers a train test split method that helps us to do the training dataset and testing dataset split. Okay, let's take a look. So from sklearn dot model selection, okay, we import this method train test split, okay. And I suggest you to shift tab after the train test split to read the documentation. So if we scroll down, you can find the example here. So I am gonna copy everything here and I'm gonna paste it over here, and we're gonna do a little bit of cleanup. Okay, so here what does that mean is it just helps us to save some typing. Okay, it helps us to define the X train, X test, Y train, Y test. Okay, so basically it will take your X that we just defined, our X array and Y array. What's the text size? In this case, we'll say 40% will go to the testing data. In a random state, you can, the default is 42, right? And let's do 101, okay? You can do whatever number you want. If you want to get the same result as mine, you can do 101 as well. Okay, so let's run this one up. And next thing is create or train the model. Okay, so from sklearn dot linear model, we import this linear regression model. Okay, and what I'm going to do is I am going to instantiate this linear regression model as an instance. So I'm going to declare a variable called lm. Lm seems like I just no. I'm just gonna declare a variable called lm, and I'm gonna instantiate my linear regression here. So basically what I've done is just create an object that will takes or instantiate my linear regression model. Okay, so lm dot. So if you press on the tab key, you can see all the methods here for the lm, right? So today I'm gonna use fit. Okay, the fit basically means I fit my linear regression model to my training data set. Okay, so if you use fit method, it takes x and y. But as I said, we will fit our model. We're gonna train it first. So it will basically be x train and y train. Okay, so if I run that, you will see that our linear regression model has been created. Okay, so next part will be the model evaluation. So we will check out its intercept and maybe its coefficient, and to see if we can interpret them. Okay, so first since it's regression model, I may ask you to print out the intercept. Okay, so print lm dot intercept underscore. That's the way how you return its intercept. Okay, so negative 2640159. Okay, and then may have to take a look of the coefficient, or say lm dot coef underscore. Okay, so it returns in numpy array that takes the coefficient. So these coefficients, they are all corresponded to my X array, right? To the feature columns. So what I can do here is I can convert that to a data frame. So pd dot data frame, and I'm gonna take my ln coefficient as my data, and x dot columns as my index, and the columns is gonna be my just give a name called coefficient. Yeah, all right. So here I have created the data frame, right? And I'm gonna give it name. So maybe CDF. Okay. CDF. Okay, so I hope you do understand what does the coefficient mean in statistics. So if not, I'm just gonna give you a brief explanation on that. So if I hold all the other feature columns fixed, okay, I only change the average area income by up to 1 unit, then I will have my housing price increase by 21.5, around $21.5. And similarly, if I hold everything else fixed, I only change, say, increase my average area house age by 1 unit, then my housing price gonna go up for this amount of money. Okay, so you might ask me, is that for real? Does that make sense? Because as I said previously, these are all artificial data. If you want something in a real world data, that I recommend you to do the, if you heard about the Boston data set. Okay, so it will give you the real world data, and you can take a look of that.